All right, welcome back. Today we are going to finish our discussion on motion. I'd like you to pause the video and do this now. Now that you've finished that, let's go ahead and go over what the answer should have been. Miss Moore walks 40.0 meters in 16.72 seconds. Ooh, fast. What was her walking speed? So let's go ahead and write down some numbers here. 40.0 meters. I also see 16.72 seconds. And my walking speed, what is her walking speed? That is what we are trying to figure out. I've got units of seconds, so that is time. And then I have meters, and that is distance. If I remember correctly, speed equals distance divided by time. I plug in distance on top. I divide it by the amount of time it takes me to do it. And then I plug it into my calculator. 16.72. And I'm going to round it to 2 places past the decimal. We're going to call it 2.40. And meters divided by seconds. Sweet. All right. So that's what you should have gotten for this, for my speed that I was walking. Let's move on here. So a little bit of review. Distance is how far something moves on a path. The path may have many changes of direction. So when we did our walking speed lab and our walk in the park lab, when I did it, we walked in one direction. But distance, you can walk in any direction you want to. So I'm going to go ahead and set this up here. All right, I'm going to measure distance. Oh, let's talk about what this is real quick. This is a trundle wheel, and every time that the trundle wheel goes around in a circle, and you hear that click, that's 1 meter. So 1 click is 1 meter. I'm going to measure distance with the trundle wheel, and my handy dandy assistant, Mr. Boykin, is going to measure time with a stopwatch.
Say go.
Ready, go. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so I had 18 clicks. So my distance was 18 meters. Mr. Boykin, what was the time?
23.75 seconds.
Okay, so from here, we know that we can calculate our average speed. Speed equals distance over time. And we can just plug this in again. I'm gonna need my calculator, gotta go grab that.
There's one right here.
Oh, perfect, yeah. So 18 meters for the distance divided by time, 23.75 seconds. Which one to pick? So many
An
options.
embarrassment of riches.
18 divided by 23.75, and my answer is, so it's I'm gonna call it 0.80 meters per second. 0.80 meters per second, that is my speed. So distance and speed have magnitude only and are called scalar quantities. All right, I'm gonna pause this right here. Magnitude. You guys are not familiar with this word. Magnitude is how big or small a number is. So it's just a big or a small number. That's what when we say magnitude, it's the number your calculator gives you, big, small, whatever. Scalar, you're just gonna have to trust me on this. Don't worry about that word right now. We're gonna come back to it later on. So distance, just the number you get into your calculator. It is magnitude in a scalar quantity. Don't worry about it. Forget I said anything. Sort of. Before I talk about this, I'm going to use my trundle wheel, and I'm going to walk from here to there without the marker. Okay, and 1, 2, 3, right there. So that was 3 clicks, which gives me 3 meters. Now, what is the difference if I walk this way? 1, 2, 3. They're both 3 meters, but I'm just changing the direction that I walk. So displacement is the shortest straight line distance between 2 points in a specific direction. So one point was right here, and the other point was right there. We are measuring displacement because we're not only going in between the two spots, but we're also worried about the direction that I'm going. And the direction is what makes it displacement. Before, when I walked around the room with the trundle wheel, changing all sorts of directions, that was distance. But ultimately, I ended right here, right?
Where did you start?
Oh, started over there,
Yeah.
ended right here,
Yes.
right? And displacement is how far and in what direction you go. So when I was talking about the distance, I could start from one point right here, and I could walk all around the room, different directions, and end in that spot over there. That's distance. But for displacement, we want the shortest straight line path to that spot, and we care about the direction. Okay? The path does not matter for displacement. It's just from point A to point B, plus the direction. Okay. The change of position is called displacement. Or delta x. And Miss Moore, what even is this triangle thing? It's called delta, and it just means change. And
It's a Greek letter, isn't it?
it is a Greek letter. And throughout the year, you're going to see this triangle, and it's going to mean the same thing throughout the year, the change of something, whatever it is. And so let's take a look at what it's asking for. So change in position. X, this is one of our symbols for position. And the change in X, the change in position, is what we call displacement. All right, so let's take a look at these other numbers and symbols. So it says x2 minus x1, or xf minus x with this funky 0 thing. Throughout the year, you are going to be given different numbers, and you're always going to have to subtract the second one from the first one, or the final one minus the initial one. That little funky 0 thing means initial, or the first one. And the reason that we subtract the second from the first, or the final from the initial, is just so that the sign isn't negative. We want the sign to be right. So these two things mean the same thing. This right here represents displacement, or the change of position.
On our number line.
On our number line.
There you go.
Yes, the change of position on our number line. So let's go ahead and do some practice problems. Woohoo! Okay, so when I ask about the way that I will ask this question is I'll say, what is the net displacement? The net displacement. Let's go ahead and take a look. So for here I have x1 and x2. So I'm using this problem. They're the same thing, but those are the right symbols and numbers right there. So I'm gonna go ahead and say delta x equals, I'm gonna say x2, which is this one. So negative 1.5 meters. Don't forget your units. And then we subtract right there, subtract it from x1, which is this one right here. So negative 5.0 meters. I'm gonna go ahead and plug that into my calculator. Miss Moore, my batteries are dead. Could we have another one? Okay. So many calculators. All right, so I said negative 1.5 minus a negative 5, and I get 3.5. Okay, I'm gonna go and write that down here. So 3.5, do not leave your number naked. You have the units of meters right here. Okay, let's move on to our second one. The difference between these questions and this question is just the way that the symbols are here. So before we use this equation, but it's the exact same thing as this equation. You can see we've got those letters here. So I'm gonna say that delta x equals, and we know it's x final, which is this one right here, negative 32 centimeters, minus x initial, which is 75 centimeters. And I'm gonna plug that in my calculator. Negative 32 minus 75. And I get negative 107 centimeters. All right, those are my answers.
Now they should do the Quizlet, huh?
What do we have next? Oh,
I'm gonna pause this.
Yeah. All right, so I want you to pause the video, and what you're gonna do is you're gonna find Quizlet 1. I'm new to this Canvas stuff. The hope is that it is in Canvas for you to do, but I'm gonna go ahead and explain what I want you to do. So it says displacement is the change of position, and we know this. We just saw this equation. I want you to use the number line to find the displacement described below. So I'm gonna do the first one with you guys. So we know that our equation is, I'm gonna actually write this up here. I'm just gonna say change of x equals x2 minus x1. So I can have it up top there. So I'm gonna say x2, I'm gonna say delta x, change of position, displacement. X2 is, I'm gonna go ahead and do the numbers first. I don't have any units here, so I'm just gonna say 5.
How do you know that that's X2?
Oh, thank you. So x2, because it's in the x2 column right here. Okay.
Oh yeah, okay. Thank you.
Yeah. So so I'm gonna go ahead and put, and I'm gonna actually include that plus sign. Okay. So plus 5, and I'm gonna say subtract because that's my sign there, and x1 is 0. I don't have to plug this in my calculator because I know this one. It's just gonna be a positive 5. And again, I don't have units right here. Otherwise, I would expect you to write units.
Ms. Moore, can I just write down the answer?
Ooh, no. So it says show work with an exclamation mark, which means I definitely expect you to show work. So you're gonna wanna make sure you have all of the math that you need to show me that you know how to do this right here. So let me go ahead and show you how I use the number line to find this, or to double check my answer. So I know that I'm starting initially, my x1 is 0 right here on the number line. And it tells me that I'm gonna go to x2 to 5. That's where I'm gonna finish over here. So I'm gonna go from 0 to 5. Okay, 5, that's my number, that's what I got, my magnitude. And then my direction is positive, right? Because this is positive on the number line. So boom, there's my answer. You guys are going to finish the rest of them. Good luck. All right, here we go. A quantity that has both magnitude and direction is called a vector quantity. Displacement is a vector quantity because it has magnitude and direction. What do we mean by this again? My magnitude was my 3 meters, right? 1, 2, 3, as I walked across. And my direction was either west or positive, if you're thinking about it like a number line. Displacement over a time period. So if you guys remember, the displacement as I walked from here, starting here, all the way around the room, and I ended over there, the displacement from one place to the next was 3 meters. Okay. So over a time period, we're gonna come to that in a second. Oh, don't freak out, okay? Average velocity, new word alert, V for velocity. Again, bear with me, don't freak out yet, don't let this scare you. We know how to do this. This top part, delta x. We just talked about this. So you guys did some problems, and lots of problems that were, correct me if I'm wrong, but pretty easy, where we just did the x2 minus x1, the change in the position, the displacement, right? So the next part, and we have that over here too. We've already solved that. We measured it, which was easy. Okay. So the next part is this delta t, this change in time, and over here it's represented by this equation, t2 minus t1. Similar, right? It only changes the variable, the letter that they use. But you know, this is kind of essentially all that you have to understand is that the time that they give you. The time it took you to that it took me to walk around the room, that's what we're going to write right here at the bottom. So my change in time was, it took me this much time to walk around the room, so 23.75 seconds. Okay, sweet. So I have my average velocity equals this divided by this, which is the same thing as this divided by this. I can plug this into my calculator and get the answer. So I'm gonna go ahead and say, on button, here we go. 3 divided by 23.75, and I get point, I'm gonna call it 1.13. 0.13 what, Miss Moore? Great, glad you asked. Meters divided by seconds.
That's awfully slow, Miss Moore.
It is really slow, and the reason it's really slow is because it took me so long to walk all the way around the room, even though the displacement from here, the start to the end, was so small. So yeah, 0.13 meters per second was my velocity. Let's go to that next slide. A practice problem. We're gonna do a practice problem together. I'd like you to get out your walking speed lab or look at it, or I'm not sure how it will work, but make sure you have it nearby so you can look at it.
Well, that was the one where we're walking on the sidewalk, huh?
Yes, we walked, you guys recorded the amount of time it took you to walk 10, 20, 30, and 40 meters. That's the lab you need. Here's our question. A student walked past 20 meters at 12.23 seconds. So they're walking, then they passed the 20 meter mark at 12.23 seconds. And then they kept walking and they walked past the 30 meter mark at 23.65 seconds. What is their average velocity? Numbers, what's it asking, Miss Moore? Breathe, average velocity equation is up here. And we know how to do this. Let's take a look first at the displacement, the change in the position, x2 minus x1. So let's start with x1. Where did we start here? Well, we started at the 20 meter mark. I'm gonna go ahead and write that right here. And where do we end at? We ended at the 30 meter mark. Okay, that part's done. I'm going to divide by the change in time. So where did when we were at the 20 meter mark, what time are we at? Well, it said 12.23 seconds. I'm gonna write that right here. And then at the other mark, the 30, we were at 23.65. 23.65 seconds. Subtract right there. Okay, so I'm just gonna do some math.
Shouldn't you use parentheses with this?
Yeah, let's do that. Okay, so here's how we do this. So I'm gonna put parentheses. I'm gonna say 30 minus 20, and I'm gonna close my parenthesis. Then it tells me to divide. I'm gonna push divide. And I'm gonna put this bottom thing all together too, because I want them to do the top one together in parentheses and divide it by everything that's on the bottom. I gotta chunk it together. So divide parentheses, 23.65 minus 12.23. I'm gonna close my parenthesis there. And I'm gonna get 0.8, I'm gonna call it 88. Equals 0.88. Miss Moore, are we done? No, we are not done. What are our units? We have meters on top and seconds on the bottom. Meters divided by seconds.
Where did those parentheses go in your calculator?
Oh, you know, that's a really good point. Let me go ahead and show you one here. So I put one set right there. Right? So parentheses, these numbers, close parentheses. Then I push divided by. And then I put parentheses, blah, 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 parentheses. And then I pushed equal. So I kind of read it like a sentence, across and then down. All right, so you have already done Quizlet 1 and finished that. Your next and last assignment is going to be this one right here. Again, my hope is that I can get it on Canvas. We'll see how things go. But this, you're gonna be calculating the average velocity and displacement. I want you to show all of your work.
What do you mean when you say show your work?
Great question. So I want to see this. Okay, I want to see, you don't have to put the parentheses in there, but I want to see that you can if you want, by all means. But I want to see you set up your work, show me what you subtracted x final minus x initial, and don't forget your number plus your units. You will lose points if you don't have your units in there. So, should I do one with them? I think they're fine.
No, that's what the Zoom classroom is for.
Ah, yeah!
Yes.
See you in Zoom.